Now this section, let's have a look IPv6. So IPv6 is Internet Protocol version 6. IPv6 serves as the replacement protocol for IPv4. So why does IPv4 need to be replaced? IPv4 is 32-bit address, few billion addresses. This number is too small as compared to devices on the internet these days. And IPv6 is 128 bits address, supplies over trillions and trillions addresses. So 2 to the power 128, that means huge amount of addresses we can configure with IPv6. So that is the main reason, like we need more addresses. That's why we have this IPv6 at this time. Now for IPv6, every protocol like RIP, OSPF, EIGRP, BGP, for all these protocol, we have IPv6 versions. All these protocol, we have IPv6 versions. It's just called RIP, next generations, OSPF version 3, EIGRP, that one called version 6, and MP-BGP, multi-protocol BGP version 4. So they are all IPv6 types. Now IPv6 address written in hexadecimal format. Hexadecimal means part of that we have this IPv6 format uses 8 sets of 4 hex digits numbers like 2340, 0111, and then all AA, 0001, etc. They're all hexadecimal number. And you can see in one block, we have 4 hexadecimal number. In this way, 0111, AA, 0001, 1, 2, 3, 4, and so on. It's going on all the way up to here. Now, we have 8 block, and each block we have 4 hexadecimal number. So altogether, we have 32 hexadecimal number in here. So 2 to the power 32, or let's say 1 hexa equal to 4 binary numbers, right? 1 hexadecimal number equal to 4 binary numbers. So 32 hexadecimal number means 32 multiply 4, which equal to 128. So 2 to the power 128 equal to that's trillions of addresses we'll be able to create. Now let's say 1 hexa equal to 4 binary. 0, all zeros, 1, 0001, 2, 0010, 3, 0011 in this way, right? We have all this hexadecimal number. Now, IPv6 address, usually they are long address. So we try to make it shorter. So there is some process with that we can make it shorter. Let's say FE00, 0000, all zeros, 0001, then all zeros like that. Now we can compress this one. We can say FE00, colon 0, colon 0, colon 1, then colon 0, colon 0, colon 0, colon 56. So how we compress? Let's say FE00. So leading 0 you can remove, but trailing 0 you cannot remove. So 00 need to be there. Then 40 we compress to 10. Again 40 we compress to 10, and 0001 we just simply put 1. After that, again 40 we put 0, 40 we can put 10, 40 we can put 10, and 0056 instead of that we can simply put 56 because leading 0 doesn't have any value. After that, let's say large consecutive 0 we can compress to double colon. So 2 or more sets of zeros you can compress to double colon, but double colon we can use only one time in one address. We can say FE00, then colon colon 1 0 0 0 56, or we can say fe00 colon 0 colon 0 1 then colon colon 56 in here. Both of them are correct. Right, both of them are correct. So you need to remember, leading 0 doesn't have any value. We can remove leading 0. But trailing 0, it's important. We cannot remove trailing 0. And large consecutive 0, we can compress to double colon. And double colon, we can use only one time in one address. So that means only one time we'll be able to use that double colon in one address. Now, IPv6, another important things. IPv6 mask is called prefix length, written as slash followed by a decimal number. Decimal number defines how many bits of IPv6 address define the IPv6 prefix. So typing the values into a Cisco router, we can write down in this way, like /64 or space /64. So without space or with space, we can put /64. And prefix length, we can put legal value ranges from 0 to 128. Now find the subnet ID. Let's say this is one of the address given to us is /64. But one thing is, this address written in hexadecimal format, but the prefix is /64, right? So a prefix is written in binary format. So 1 hexa equal to 4 binary. So we can divide it, 64 we divide it by 4. In this way, we can get the 16 hexadecimal number, right? So 16 binary bits and 64 binary bits equal to 16 hexadecimal number is the same thing. This is in binary and this is in like normal hexadecimal format. Now, when you have a /64 or /16, what we do, we keep the 16 digits as it is and remaining values we put 0. We need to make 8 block, right? So we keep the 16 digits as it is and remaining values we put zeros. And this is the subnet ID. Okay, that. And we can compress this one and you can put simply double. So pretty much that's the subnet ID. It doesn't have any subnet mask. There's no magic number. There's no other calculations. So simply we can find out the subnet in this way. Because IPv6, we got plenty of addresses and prefix, just it works with prefix. Now find the subnet ID. Let's say we have all these address and /56. So what we do at first to find out the subnet ID? 56 we divided by 4, correct? In this way, we get hexadecimal number. And then we keep the 16 digits from this IP address and remaining values we put zeros, correct? Yeah, just keep the 14 digits as it is and then remaining values we put 0. In this way, like you have, we need to keep the 32 hexadecimal number. So we have 32 hexadecimal number, and after that we can compress like that, correct? This is subnet ID. But can we write down like that? Can you remove those 0? Correct. So this is incorrect. We cannot remove those zeros. Yeah, correct. So IPv6, we have many addresses, correct. Now let's say IPv6 address types. We have global unicast address. Any address start with 2 or 3, they are called global unicast address. Global unicast means similar to IPv4 public IP address. So any address we see start with 2 or 3, they are actually global unicast address. Then we have unique local. Unique local is FD. Any address start with FD, we call them unique local. Then multicast address FF. Sorry, unique local FD. FD means private address. Any is similar to IPv4 private address. Any address start with FD. Oh, there's a new address, new name. Yeah. Multicast FF. Any address start with FF called multicast. This is similar to IPv4 224 block. We have similar to that. Then link local. Any address start with FE80, they are called link local. Link local address generated automatically. Link local address start with FE80. This address automatically generated. IPv6 link local address is important because IPv6 with that link local address, they communicate internally with another IPv6 device. So that's why it's locally it's important. Link local address start with FE80. Now unspecified means all zero, colon, colon. And loopback address, colon, colon, 1. Now IPv6 support another dynamic address assignment process other than DHCP called stateless address auto configuration or SLAC. So SLAC is another process with that automatically based on the port MAC address, we can generate the IPv6 address. Because MAC address is written in hexadecimal format, IPv6 is also hexadecimal format. So that's another method we have to generate IPv6 address. Now IPv6 multicast address. So broadcasts are not supported in IPv6. So broadcasts are not supported in IPv6. So prefix FF00 colon colon /8 IPv6 multicast address. IANA reserves all that begin with FF02 colon colon /16 link local multicast addresses. So all nodes, let's say multicast address, we have FF02 colon colon 1. That's multicast address, meaning all nodes. So we do not have any broadcasting in IPv6, mostly multicasting, and there are some reserved addresses for each of the types of communications. Let's say all nodes means all PC server, they communicate with FF02 colon colon 1. This is similar to IPv4 broadcast address. All routers, they communicate with FF02 colon colon 2. All OSPF network, they communicate FF02 colon colon 5 and 6. All EIGRP, they communicate with FF02 colon colon A. In this way, like all other protocol, they have fixed multicast address. With that, like if they want to communicate within that protocol, they're using this kind of multicast addresses. And they have equivalent IPv4. Some of them, they have equivalent IPv4 multicast addresses. Now, IPv6 global routing prefix. Global routing prefix is a set of addresses that only one company can use it, like a network number of public IPv4 addresses. All the IPv6 addresses inside the company should begin with that global routing prefix. Let's say we have company 1 2001 colon db8 colon 1111 colon /48. So in this way, like company will get one prefix. Then company 2 get 2222 colon /48. Company 3 is getting 2001 db8 3333 colon /48, etc. So all we have router 1, router 2, router 3. So all this individual block we have. Now, global routing prefix example. A company receives GRP, global routing prefix. Global routing prefix is 2001 0db8 colon 11 colon /48. But how this address assignment works? So IANA, Internet Address Number Assignment, they are the organizations who look after all these IP address and everything. So they assign one block based on the region. Let's say you have North America, Erin, and then Afrinic, which is Africa, another block. In this way, ISP will get the second block, and then company will get the third block. Right? In this way, you have multiple block available. So in this way, like based on your region, based on your ISP, company will get one block. After that, the company gets the global routing prefix 2001 db81111 colon /48. The company uses the usual 64-bit interface ID. The company has a subnet field of 16 bits, allowing for 2 to the power 16 equal to 65,535 IPv6 address. So let's say 3 block you get from ISP. After that, in IPv6, always 16 hexadecimal number, this 4 block or 64 bits, right? 16 hexa equal to 64 bits. So always 64 bit will be for host. And then in the middle, you have another 4 hexadecimal number or 16 bits. So 2 to the power 16 means 65,000 subnet you can create. So only from this address, you can create 65,000, and for each subnet, you can have billions of addresses. So that's huge addresses you can have with these calculations. So breakdown is, let's say, global routing prefix you'll get from ISP, and interface ID or host ID, this is another block. In the middle, you have a subnet ID. In the middle, you have the subnet ID. Right? In this way, we have prefix bit, subnet bit, and interface ID. Now list all IPv6 subnets. Find all unique values that will fit inside the subnet part. So how to organize the subnet? Simply say 2001 0db8 1111 0001. In this way, 0001, 0002, 0003, 4, 5, they are all subnet. And colon means you have many addresses for host, but there's no other complex calculations, but simply you just need to make them they are separate. 001, 2, 3, 4, 5, 6, 7, 8, 9. In this way, you can configure each of the subnet. And once you configure subnet, let's say for this one is one subnet, under that you have two IP address. From this subnet, you have one IP is here .1, and then from here .1, like that .1. All this IP address will be there. Right? Then assigning the IPv6 to host in a subnet. So once you have that subnet, from that individual IP address will be there, like 1::2, 1::1, like that. 2::1, 2:. So from each of the subnet, individual IP address will be there. Right? So it's actually simple assignment. So usually how it works, let's say, if I go to my notes in here, if I write down one address 2001 colon, let's say we have 2001 colon 1 colon /64. This is one of the subnet. Yep, I can put another one as well. It's many different way you can create subnet. So what is the full form of this one? Let's say I can say 2001 colon 0001 colon 0001 colon 0000 colon. It's the same thing, right? Same format. Let's say 2001, I put 2001, 0001, I put 1, 0001, I put 1, and remaining values large consecutive 0, I put double colon. That's my subnet. And from this subnet, I can put my first IP 1, second IP 2. In this way, we can assign IP address. They'll give you one block here. Yeah. In this way, you can create subnet. Let's say this is your subnet number 2. In this way, you can create. Based on your requirements, you can have IPv6 because we have huge addresses, so everyone can have public IP address. We have private IP address. If required, you can use that one as well, but public IP address available for everyone. Yeah. Yeah. But when you create subnet, you can create in this way. Let's say you can put other values or whatever value they provide, but simply remaining values means we have zeros over there, but we can write down in this way. Now, in this way, we can assign, like once you have IP, we can assign for each of the interface. Now, unique local address. Unique local means your private address. You can also configure private address. Private address means your first 2 digits should be FD. That's a private. This one should be private FD. And then we have 40 bits, which is global ID. And then 16 bits will be here. And then interface ID will be there. Okay, 8 bits, then 40 bits, and then we have 16 bits. So main point is first two digits should be FD, and then remaining block you can make up. Private, yeah, unique local. FD 00 colon, you can put 0001, 0001, 0001 colon colon. So you can make up that part. Private address, you can put anything, but you need to follow the format. FD and then rest of the values you can put by yourself. Okay.
How do you work out the math to see how many public addresses for the 48 bits?
Mm-hmm.
We work out.
They will give you /48, and in the middle, after 64 bit is always for host. 48 bit you get from ISP. In the middle, you have 16 bits. That is your subnet bit. Now, 48 bit, you cannot change. It's fixed. You don't make any changes with 48 bit. You just keep as it is, which one ISP given to you. But after that, this 16 bits is your block. You can make changes in here. Always 64 is for host and 48 bits given by ISP. In the middle part, 2 to the power 16, 65,000 subnet you can create. Yes. Yeah. They will give you this block after that. Yeah. So huge number of address we have. Now, static unicast address configurations. Statically, two methods are used to configure IPv6 address. Number one, configure the full 128-bit address. For example, 2001, 1111, colon, colon, 1. You can write down everything in full format. Or method two, configure 64-bit prefix and let the router derive the second half. 64 means second half you can configure. So IPv6 routing, we have IPv6 unicast routing. And so how to enable, we say at first IPv6 unicast routing, and then we take the interface gig 00, IPv6 address 2001 TB8 1111 colon 1 colon colon 1. And then interface serial 000, then IPv6 address 2001 0D. This is a kind of full format, like all the digits has been applied, but in this way we can write down IPv6 address for any interface. Or there is another method that is called UI64. UI64 means at first we say IPv6 unicast routing. We enable the IPv6 inside the router. Then we take the interface and say IPv6 address. We put the subnet informations, but in here we did not put the IP address. We just put the subnet info space UI64. So this UI64, it will generate new IPv6 address based on this port MAC address, because every interface or port they have the MAC address, right? MAC address written in hexadecimal format. So UI64 will convert that hexadecimal format to IPv6 address format. That's the UI64 method. This is one of the options we have. Is you don't have to use this one, but they have these options available. Correct. Now, verifying IPv6 settings. Show IPv6 interface brief. part of that gives you interface IPv6 address info, but the prefix length info. So you can see all the show command, they're remaining same. Just we put, instead of IP, we put IPv6. Show IPv6 interface, you can say show IPv6 interface gig 00. In this way, we can configure.
You have IPv4 and V6.
Yes, you can have. They coexist, yeah. You can have both, no problem. Same router, you can have IPv4 all configurations and IPv6 all configurations, no problem. Now, the neighbor discovery protocol is called NDP. So this is similar to address resolution protocol or ARP. Address resolution protocol, it's identify the MAC address connected to a host and host IP address. So NDP can identify similar sort of things, but NDP we're going to use for IPv6 environment. Now, NDP, what it does the neighbor MAC address discovery. So every devices, we have the neighbor discovery. So basically they discover the neighbor MAC address and check whether MAC address is okay or not. So basically it's learning the MAC address for the neighbor, and then router discovery. It can identify the router in the same subnet, and also Slack. Slack means stateless address auto configurations. It can generate the IPv6 address automatically. Then that duplicate address detections is basically address duplications, duplicate address. If any other device has same or similar address, it can identify that stuff. So if any duplications happen, it can identify the duplicate address. Now, IPv6 routing types, the configurations of IPv6 address on working interface. So routing types is similar. We have connected route, local route, static route, dynamic route. All these routing types we have similar to IPv4. Now, static route, how it functions, we can say IPv6 route, destinations network, which is 2001 colon DB8 colon 1111 colon 2. So this is my source subnet, this one in router 1, and then router 2, this is my destinations network or subnet. So you can say IPv6 route, destinations network, and my outgoing interface. Or I can say IPv6 route, destinations network, and next hop, IPv6 address. Both of them are correct. You can configure whichever is convenient for you. Both of them will work. As you can see, IPv4 and IPv6, they are very similar. Only thing, just even the syntax similar. Only things, the address is IPv6 in here. Now, static default routes. So let's say we'd like to send traffic. So we have this is a branch router B1, and this is a core router. So from the branch router, we can send the traffic to core router. So how to send? From branch router, we can configure default route. Let's say IPv6 route and /0, and you can put your outgoing interface. In this way, branch router will send all the traffic out from this serial 001 interface. So whatever is connected, traffic will go there. You can see the default route concept also similar, but only thing, just the address is bit looks different. So in IPv6, in this way, we can configure default route. Also, dynamic route, part of that we have OSPF. Let's say OSPF for IPv4 and IPv6, there are many similarities we have. Let's say both are linked state protocol. Both use the same area design concept and design terms. Both require that the routing protocol be enabled on an interface. Both attempt to discover neighbors connected to the data link connected to an interface. Both perform a check of certain settings before a router becomes neighbors with another router. After becoming neighbors, both OSPF version 2 and 3 proceed by exchanging the contents of link state database, link state advertisement that describe the network topology. Both OSPF version 2 and 3 use the shortest path first algorithm to calculate the routes. Both use the same matrix concept based on the interface cost. So you can see there are many similarities. Both IPv4 and IPv6, they have many similarities. But differences mostly internal with configurations or structures of the LSA, means link state advertisement. So maybe some difference we have over there. But configurations, more direct approach to configurations, enabling OSPF version 3 on each interface using an interface subcommand. So OSPF version 3 router ID. So router ID is 32-bit. OSPF version 3 is the router ID, is the 32-bit. It is also represented in decimal dotted number, which is DDN. OSPF version 3 uses the same rules as OSPF version 2 to select the router ID for OSPF. If no IPv4 configured on router, you must use the router ID command. So that means in IPv6 also we need to configure router ID, but it need to be in IPv4 format. Let's say 1.1.1.1, 2.2.2.2 in this way. If no IPv4 configured on router, you must use the router ID command. Now, OSPF version 3 configurations, how to configure. See, in OSPF, we say IPv6 router OSPF 1. 1 is a process. And then we put a router ID, which is 1.1.1.1. And then after that, we take the interface, say interface serial 000, and say IPv6 OSPF 1 area 0. In this way, we can configure the interface. Okay. And you can see you can simply configure in the interface. There's no subnet mask, there's no wildcard mask. So simply we take the interface and say IPv6 OSPF 1 area 0. So all the OSPF we can enable inside the interface. Now with the passive interface configurations, passive means if you make any interface as a passive, they'll not send any hello message, they'll not receive any hello message. Basically, that interface will be passive. It will not make any neighbor relationships or advertise anything. So sometimes some interface, let's say, is not doing anything. On that scenario, we can just make that interface as a passive interface.
You don't tell it what network.
In the configurations, no. Yeah, you just enable OSPF, you just enable in the interface. That's it. Because we do not have any network ID or wildcard mask in this way, so we don't have to configure any of these systems. Yeah. Yeah. And all the show command, IPv4 and IPv6 show command, they are very similar. Show IPv instead of IP, you just put IPv6 OSPF, IPv6 protocol, IPv6 interface. That's pretty much. So all the show command instead of IP, just put IPv6. Now let's have a look at the configurations. So let's take a new topology.